shortcut was MATLAB. B for Buckingham. M for mass, T for time, and L for length. The first priority will be given to mass, second priority will be given to time, and third priority will be given to length. Hello and welcome again. In this lecture, I am going to tell you something about the Buckingham pi theorem. Basically, I will tell you some shortcuts related to the repeated variable that will be used. Here, number of pi terms will be m by m minus n, where m is the primary dimensions. And in the fluid mechanics, there are three primary dimensions, that is mass, length, and time. But in thermodynamics, there are 4 primary dimensions, that is mass, length, time, and temperature. Then what is total number of variable? Suppose there is a function given, discharge, and you know very well discharge is a function of density, area, and velocity. Then what is this form of function? This is called explicit function, or you can simply write in this form. And this is called implicit function. You can use or you can write any one of the two, either in implicit form or in explicit form. These are the very basic that you need to know. Then Buckingham pi theorem said that their total number of terms will be, pi terms will be m minus n, where I have already told you that now m is equals to total number of variables. Then how many total number of variables are there? 4. 1, 2, 3, 4. These will be m, total number of variables. Then what is n? N will be the number of primary dimensions, and I think you know that there are 7 numbers primary dimensions, but in fluid mechanics we generally use 3, that is mass, length, and time. But in thermodynamics we use 4 primary dimensions: mass, length, time, and temperature. These are the basics that you need to know. Now we will move further and know that how to find number of repeated variables. So what are the repeated variables? Repeated variables are geometrical quantity or dynamic quantity, and third one is kinematic quantity. I will tell you some shortcut how you can easily define kinematic quantity, dynamic quantity, or geometric quantity. Now just let me remove all these things. Now see, there are 3 types of quantity that we need to define. The first one is geometrical quantity, the second one is kinematic quantity, and third one is dynamic quantity. Why only these 3 quantities? Why only these 3 quantities? Because we have chosen n primary dimensions. Primary dimensions as 3. That's why we use only 3 types of quantities. In thermodynamics there are 4, then we need to define one more quantity. One more thing that you need to remind, that I have already told you in my previous lectures that units are very important. Units are very important. Because to recognize any quantity, you need to see that what is the unit given. Suppose in any question it is not written that Q is discharge, then how will you remember that? How you will recognize that Q is discharge? The unit, the main thing is unit. The unit will be meter cube per second. Then you can simply say that Q is discharge. So you need to remember that what is the unit of any dimension. Any dimension, what is the unit? Because on the basis of unit, we are going to define geometric, kinematic and dynamic quantity. And what is the shortcut? Shortcut is MATLAB. MATLAB is a type of software, but simply MATLAB. Okay, just remove A, then it will be MTLB. B means Buckingham. And M means mass. T means time. And L means length. Now suppose the first priority we will give always to mass. First priority will be given to mass. First priority will be given to mass, second will given to time, and third priority will be given to length. Okay, now I need to erase this because board is smaller, so I need to rub this again and again. Now what was the shortcut? Shortcut was MATLAB. B for Buckingham. M for mass. T for time. And L for length. The first priority will be given to mass. Second priority will be given to time. And third priority will be given to length. Why I am telling you? Because unit is very important. On the basis of unit, we can easily recognize which quantity is dimensional quantity. Sorry, which quantity is the kinematic quantity, which is dynamic quantity, and which is geometric quantity. Suppose what is the unit of quantity? What is the unit of discharge? Discharge is meter cube per second. Meter cube per second. Then you can simply say that there is mass. No. There is time. Yes. Then this unit will be kinematic quantity. Kinematic quantity. How kinematic quantity? How kinematic quantity? There is two types of quantity. The first one is kinetic quantity, kinetic, and the second one is kinematic. Then you can simply say that there is only M, then it will talk about only motion. There is no M, then it will talk about motion plus force. Motion plus force, and this is also called as dynamic. Dynamic means force and motion, whereas kinematic there is M, that is only for motion. Okay, geometric means there will be only one dimension. Then there is time. Time means kinematic. And what is the unit of force? F. And remember, it always been MKS. MKS. Then it will be kg meter per second square. Then what is our shortcut? The first priority will be given to mass. Is there is mass? Yes. Then it will be dynamic quantity. Dynamic quantity. Now one more example. What is the unit of area? Area is meter square. Then our shortcut called the first priority given to mass. Is there mass? No. Second priority is given to time. Is there time? No. Is there length? Yes. Then it will be kinematic, oh sorry, then it is called dynamic geometric quantity. Geometric quantity. And one more thing, you need not to remember what is geometric quantity, what is dynamic quantity, what is kinematic quantity. If it is written in the question that you have to write geometric quantity, kinematic quantity and dynamic quantity, then it is important. If it is not written, you need not to remember what is geometric quantity, what is dynamic quantity and what is kinematic quantity, because you simply write now what is pi 1. Pi 1 is geometric, kinematic and dynamic into one and one more term. Then you have to directly write this one. Why you will write kinematic, dynamic and geometric quantity? Why? No need to need to write all these things. Okay, this is our final step to define pi term. Number of pi terms, you know that number of pi terms m minus n. Okay, then number of repeated variables m. In fluid it will be 3. The 3 geometric, kinematic and dynamic. Okay, then what about the others? That some variables will be, remember, some variable will be there, some variable there will be left. Then what about that? And that will non-repetitive. That will be non-repetitive. Then the first one will be the pi 1 will be number of repeated variables that I will write as geometric g, kinematic k and dynamic d, and the extra term will be written as x. Okay, then the number of first pi term will be g, k, d and x. If you will not write subscript, then it will be a journal A, B, C and D. Sorry, there will be no power. This is the journal form of pi term. Pi term, if you need to define the first pi term, then pi 1 will be G A1, K B1 and D C1, and the fourth term will be without any power. Without any power. The fourth term that will be non-repetitive will be without any power. Without any power, and this is the quantity, not unit, because after that you have to write the units and just simply drive this on that dimensions. What will be the second pi term? Second pi term will be G A2, K B2, D C2, and again this will be, if this will be x1, it will be non-repetitive, so other term will be x2, and there will be also no power. What will be the third pi term? The third pi term will be G A3, K B2, B3 and dynamic, D C2 and the non-repetitive one third, and there will be no power. I think you have understood how you can easily find geometric quantity, kinematic quantity and dynamic quantity. Basically this lecture was only for the shortcut, not for the concept. You can easily write from any book, but how to remember, how to recognize dynamic quantity, kinematic quantity and geometric quantity, this is based on this one. And what is the trick? Again, the trick is MATLAB. Buckingham uses mass, time, length by priority wise, first priority, second priority, third priority. If there is mass, it will be dynamic quantity. If there is no mass, then we have move for the second one. If there is time, it will be kinematic quantity. Suppose if there is no mass and no time, then it will automatically geometric quantity. I think you have been understood. If there is any query, you can write in the comment box. Okay, meet you in the next lecture. Thank you.